I'm going to present some data that we recently put together and compared it with the recent models in a paper we published in December. Some of you may have seen this, but maybe most of you have not. So what I'm going to do is to actually introduce this subject by reviewing some work that an undergraduate student of mine had done. I'd asked him to take on the subject of what was the temperature history of the Earth, so we get some idea as to the magnitude of the temperature changes that we're measuring. This is not, this is merely a pedagogical thing, and what I'm showing you is in the literature somewhere. We just put it together, and I'll run through this rather fast. All right, this is what I just said. My talk is in two parts: a little bit of the history of the temperature of the Earth, and then the results that I'm going to present to you. All right, here's a graph of the temperature of the Earth from the beginning, starting with the birth of the Earth, which we're not familiar with. And the scale here is 100 million years, a billion years. And what I would just want to call your attention to just two quick things. One is that the range of temperatures over here, they span around 25 degrees from maximum to minimum. This is comparable to the difference between winter and summer in Rochester. So that's to calibrate it. So this is over the entire temperature history of the Earth. The other thing I would point out is that the minima, there's 4 or 5 of these designated minima, and they occur whenever land mass is at the South Pole. That allows ice to accumulate and not in the water. So that's when the Earth is at its coolest period. Now I want to quickly change the scale on this, in which now the temperature scale is 5 million years. And what we boogie a little bit here.
Forget the talk, carry on with the dance.
What I want to call your attention to is, in this graph, is the blue curves are the familiar ice core oscillations, say from the Vostok, but the orange curve is a continuation of this and joined on nicely with some marine core data over its entire range, and that these oscillations are in fact real. It's not noise. The period of these oscillations is 41,000 years, and that corresponds to one of the astronomical periods. That's the tilt period of the Earth's axis is at 23 degrees right now, but it varies between 20 and 26. And this period causes the northern hemisphere to intercept more of the sun's energy, and causes it is the driver, it is thought, for these oscillations. They join on smoothly, but I want to call attention to the fact that there is a trend line here which is negative. The Earth is cooling off and has been cooling off for the last 5 million years. Here's the same curve, now at a different scale, just 1 million. This is 1,000. And now the oscillations in red and blue are the ice core oscillations, as we're familiar with. The trend line is still shown here, still negative. And the point I wanted to make is that the other point is that the green line is the present temperature of the Earth. So for the last million years, the Earth has been cold more often than it has been hot. And that the hot, here we are right now. This is what it was 100,000 years ago, and so forth and so on. These are previously warm periods. And we are due, according to this analysis, to go into another ice age in about 5 to 10,000 years. I give this talk in the locally around the Rochester area, and for those of you who are interested in making money, I would buy real estate in North Carolina and Florida. because all the Canadians will be coming south. They'll be under ice in another 5 to 10,000 years. Not a single one of them will want to stay there. And so you can sell your land to them. That's just the opposite of global warming. Okay, now I'm going the other way. All right, this is just to complete the gap. I'm trying to get to the present now. Here's the Holocene era. Here, this is to the left, to your left, is the glacial period, and now we're coming out of this. This whole region here is the so-called warm period, and here's the Holocene maximum. Holocene means the last 10,000 years, and it's called a maximum because the temperatures after that are less. We're headed towards another ice age. And then a little bit further on goes down, and then we're more familiar now with the medieval warm period. That's when, I'll show it the next one. This is from the IPCC report 1995, in which, in this report, there was a medieval warm period and a little ice age. It disappeared in 2001, and now I think it's come back. This is my comment on the hockey stick. All right, now we get to the present. This is the time of the instrumental record, begins back to 19...
Can you speak more into the microphone? I can't hear you in the back.
Okay, I'll try to speak closer to the microphone. Ross just commented on in the other talks, and Bowling talked on this too. I just want to point out that the data that I'm talking about concerns this region here from 1979 to the present, at least the paper that I'm going to report on. Here is my version of the slide made up a week ago of this data, which you've seen at least twice now, showing two plots. The top plot is the surface temperature data from the Hadley group, Hadley Center, and the lower curve is that from the University of Alabama, the LT section. And the maximum has been commented on a number of times, and just recently the minimum of last month, in January of just last month, and I too am waiting in the next 2 or 3 days to find out what the February value is going to be. And comment last night was that that one should pay attention to, or one should note that this is in fact due to El Nino, and this drop here is probably due to La Nina, and this is not due to global warming, but that should be underscored. It's not due to global warming. Here's a change of nearly 1/2 degree in 10 years, which is comparable to what the global warming hypothesis says you should get in 100 years. Now, which of these should you be more afraid of? I just pose that as a question. All right, now I want to set up the global warming discussion. I'm following, I'm just repeating again what other people have said. There is agreement among people on either side of this on at least 2 points. CO2 is increasing, atmospheric CO2 is increasing, and that there is some warming in the last 25 years. But the disagreements come next in how much of this is due to carbon dioxide, and whether or not there's any positive feedback. I will assert or attempt to prove that, that there is no proof that there is positive feedback. But let me continue and perhaps get into the question period on that. I want to set this up by showing a diagram which Dick Lindzen uses from time to time, pointing out that the global warming due to carbon dioxide is strongest not at the surface, but higher in the atmosphere at around 7 to 8 kilometers. So that's where the action takes place, not at the surface. We just happen to be living at the surface, But an ideal experiment would be to put a space station up there and measure the temperatures there and do all of our references from that location from a scientific point of view. Okay, now we begin discussion of the work that I've done with collaborators. This is a paper that I published with a student of mine and Fred Singer in 2004. And what it shows is, there's four, but just look at this one here. It shows that the trends increase with altitude, and there's a maximum there, just as I said. And this is what I've just indicated is the models. The models show this. They're proud of this. This is what they say it does. This is what it does do, what we find it does. What is different in that we took the data here and showed that the data were negative, whereas the positive results are from the models. And this paper was ignored, more or less. What comments there were that we were cherry picking, and that and besides that, there were uncertainties in the observations which were large enough to that one should not pay attention to it. No, this data should be uncertain. So we kind of accepted that, but nevertheless we going back again to the models. This is again what the models show, that this is a different plot, but what you want to see on this plot is that this is altitude vertical and latitude horizontal for four different models, and that this hot spot represents the warming that I've indicated in the plot. Now in the data that I'm going to show you, we take data at the equator and go vertically and measure this quantity as a function of altitude. But again, this emphasizes that the modelers all agree that there should be this warming at the higher altitudes. All right, here's the paper that we just published. Only one figure in the whole paper, in which we measured we took the models. One of the criticisms of a previous paper was that we only chose 3 models. These were the 3 most popular models at the time, but yet we were accused of cherry picking. This time, we took them all, every one that's ever been considered seriously. All this data is deposited at a weapons laboratory in California. I don't know why, but that's where it is. And it took a long time actually to do this data, but there are 22 of these models, and we took them and took an average, and here is the solid red curve. The thinner red curves are the 2 standard deviations of the model mean. Again, none of the models should complain that we've done anything wrong with their data. They will agree with us that this is correct. This is what they found. This is what they say they found. Say the models do. Now here's the difference. This time we took not 3 data sets, but we took all available data sets we could find. There are 10 of them altogether here, if you count them, 3 at the surface, 5 here, and 2 more over here. That should add to 10. All right, the data here, called the observations, are the radiosondes. 5 minutes, okay. Then they're off to the right are the satellite measurements by University of Alabama at Huntsville, and then the other group, another group that are called RSS, and then a third group here. Now the point I want to make here is that the equivalent values derived from these models are up here. So these satellites should be these MSU satellite measurements should be compared to these points. Again, except for the surface, there is no overlap. That's the point of our paper, that there's basically no agreement except at the surface. Okay. All right, this is a quick summary of that paper. I've already said this, so I'll just skip over this. And we conclude our paper by saying that there's been great improvement in the last 25 years in both the observations and the modeling, but yet they still don't agree. And we strongly caution against using these models, which are the models they use to project 100 years into the future. And can you trust these models to predict the future if they cannot explain the past? The answer, I hear a yes? Okay. Again, this is a summary. In red is what I want to emphasize as a scientist, according to the rules of science that I understand. If a hypothesis disagrees with the observations, then that hypothesis is wrong. Okay? Did I get a bad education? And here's some references. I'll clean this up later. And this is the last slide, but not really. This is a Glenn Millen false ending. There's one more thing I want to say. We just recently, this is not published and almost written up, but not quite. We take the same 22 models all over again, same observational data, but now we've gone to a different temperature, a different time period, 58 to 78. And now if you remember, I'll show you this slide again. The first paper was over this region where the temperature is increasing, but now here's a region between 1950 and 1980 where the temperature is decreasing, according to everybody agrees on that too. But now here is the kicker coming on right now. This is new data. Nobody's seen this before. Well, except me. Okay. This looks very much like the curve that I just showed, except now there is total disagreement everywhere. And this is something the models have really got to answer to. They don't get the surface right anymore. It's now positive according to the models, whereas the data is everybody, even the models agree the data is negative. But why is it that their theories show a positive trend? Okay, this is